Hello, my precious friends. I really hope that you're doing great. Welcome to today's class. It's our 5th lesson on a given Form 4 mathematics topic called differentiation. So we are looking at our third aspect on this particular topic, which is called stationary points or turning points. Now, the key point that you need to note as far as stationary points or turning points are concerned is that at the stationary point or at any given turning point, the gradient function which in most cases will be denoted by that is dy dx. The gradient function dy dx is always equal to 0. So at any given stationary point or turning point, the gradient function, which is always dy dx, will always be equal to 0. Now, there are three types of turning points. The first one is what we call a maximum point. Now, at the maximum point, the second derivative, which is always written as d squared y over dx squared, will always be equal to a negative value. This one will always give you a negative value. This one will give you a negative value. So on a given curve, for example, this is what we are calling the maximum point, the highest possible point on any given curve. So at this particular point, this is what we are calling the maximum point. This is our maximum point. So at this particular point, we are saying that the second derivative, d squared y over dx squared, will always give you a negative value. You'll always get a negative value. Then we also have what we call the minimum point. At the minimum point, the second derivative, which is always denoted by d squared y over dx squared, will always give you a positive value. This one will always give you a positive value. So on our curve, this is what we are calling the minimum point. So we are saying that at the minimum point, at this particular minimum point, the second derivative, d squared y over dx squared, will always give you a positive value. Then we also have what we call the point of inflection. So at the point of inflection, the second derivative, which is denoted by d squared y over dx squared, will always give you 0. The second derivative will always give you 0. On our curve, this is what we are calling this, that is the point of inflection. At this particular point, this is the point of inflection. Remember, a point of inflection will always separate the maximum point and the minimum point of a given curve. So at this particular point, the second derivative, d squared y over dx squared, will always give you 0. This one will always give you 0. So that is what you need to know as far as stationary points are concerned. So at any given stationary or turning point, the first derivative or the gradient function, which is dy dx, will always give you 0. At the maximum point, that is the highest possible point on any given curve, the second derivative, that is d squared y over dx squared, will always give you a negative value. At the minimum point, the second derivative, which is d squared y over dx squared, will always give you a positive value. Then, of course, at the point of inflection, the second derivative, d squared y over dx squared, will always give you 0. So this is the maximum point. The second derivative is a negative value. The point of inflection, second derivative is 0. Minimum point, the second derivative will always give you a positive value. So we check example 12, which is a past Kcse question that was tested in 2014, paper 1, question number 24. It reads that the equation of a curve is given by y is equals to x cubed minus 4x squared minus 3x. So part A of the question, they want us to find the value of y when x is equals to negative 1. Now remember, the equation was given as y is equals to x cubed minus 4x squared, then of course minus 3x. So they want us to find the value of y when x is negative 1. So we just gonna substitute. So y will be equal to when x is negative 1, we're gonna have negative 1 cubed, then minus 4 into negative 1 squared, then of course minus 3 into negative 1. So this will be equal to negative 1 cubed will give us negative 1. Then of course this will be negative 4 into negative 1 squared will give us positive 1. Then of course minus 3 into negative 1. So this will be equal to negative 1. Of course negative 4 times 1 will get negative 4. Then negative 3 times negative 1 will get a positive 3. So this will be equal to negative 1 minus 4 will give us negative 5. Then of course plus 3. So the final answer will be negative 5 plus 3. We are going to get negative 2. So that is the answer for part A of the question. So we move to part B, whereby we are told to determine the stationary points of the curve. We've said that at the stationary point or at the turning point, the derivative, the first derivative, should always give you 0. So we'll say at stationary point, at any given stationary point, at the stationary point, at any given stationary point, the first derivative, that is dy dx, must always be equal to 0. Therefore, we'll get the derivative dy dx. So that means we are going to differentiate the given equation. So of course, the 3 will pre-multiply the coefficient. So this will be 3 x to the power of, we subtract 1 from the power. So this is 3 minus 1. Then we pre-multiply the coefficient with the power. So this is negative 4 multiplied by 2. Then of course x power 2, we subtract 1 from the power. Then this was power 1, so we pre-multiply with the coefficient. So negative 3 times 1, x power 1 minus 1. So this will be equal to 3x to the power of 2, then minus negative 4 by 2, I'll get negative 8x to the power of 2 minus 1, I'll get power 1. Then of course minus 3x to the power of 0. So this is going to disintegrate into the following. So we're going to have the following. So that means our dy dx will be equal to 3x squared, then of course minus 8x, then of course minus 3, because x power 0 will give you 1. 1 times negative 3, you're just going to get a negative 3. Then you are saying that at the stationary point, the derivative must be equal to 0. Therefore, this must be equal to 0. Therefore, to get the stationary point, we are just going to solve this particular quadratic equation. So I'm having 3x squared minus 8x, then minus 3 is equals to 0. So this is a quadratic equation in the form ax squared plus bx, then of course plus c is equals to 0. So clearly the value of a will be equal to positive 3, the value of b will be negative 8, then the value of c is negative 3. So we get the product, that is I'm using factorization method. Product is usually a times c, which will be equal to a is 3, then c is negative 3. Of course, this will give us a negative 9. We're gonna get negative 9 as our product. Then the sum is usually the value of b, which is equals to a negative 8 in this particular case. So of course, to get the numbers, we usually get the factors of the product. So by 3, of course, this will give us 3. Then by 3, this will be 1. So we need two numbers. When multiplied, we get negative 9. When we add, we get negative 8. Of course, the numbers will be 3 and 3, which will be 9. Then, of course, I'm going to have a 1 here. So my numbers will be 9 and 1. But I need that when I multiply, I get a negative 9. So, of course, this will be negative 9 by 1, I'll get negative 9. When I add negative 9 plus 1, I'll get negative 8. So the numbers are negative 9 and, of course, 1. Once we do that, of course, we're gonna substitute in the value of b. So the equation will be 3x squared, then of course plus the values of b. I'm having -9, then of course plus 1, then of course x. Then I continue with my equation, minus 3 is equals to 0. So this will be 3x squared minus 9x, then of course plus 1x, then minus 3 is equals to 0. Then I'm gonna factorize the common terms. So the common terms between my first two given terms, that is the common term here, of course, is 3x. So I'll factor out 3x into 3x squared over 3x. Of course, I'll remain with x. Then minus 3 into 9, that will be 3. Then, of course, the x will cancel out. So I'll remain with 3x into x minus 3. Then the common term in the last two terms, of course, will just be +1. So I'll factor out a +1, then into, of course, 1x over 1, I'll just get x, then minus 3 divided by 1, I'll still get 3. Then, of course, this was equal to 0. So I'll group this one and this. So I'll have 3x plus 1 into bracket. Then I pick one of these brackets. X minus 3 is equals to 0. So it means that either, so the solutions will be, I'll say either 3x plus 1 is equals to 0, which simply means that 3x will be equal to -1 over 3 over 3. So this one simply means that my x will be equal to -1/3. Or the second bracket was x minus 3 is equals to 0, which means that x will be equal to +3. So those are the two possible values of x. But part B wanted me to get to determine the stationary points, the stationary points. So for me to get the stationary points, I need to have the values of y. So I'm gonna substitute in my given equation. So the original equation was y is equals to x cubed. This was x cubed minus 4x squared, then minus 3x. So when x is equals to -1/3, that is the first solution here, my y will be equal to, this will be -1/3 cubed, then of course minus 4 into -1/3 squared, then of course minus 3 into -1/3. So this will simplify to, of course, this will give me -1 over 27. That is -1 cubed, you'll get -1. 3 cubed, you'll get 27. Then minus 4 into -1 squared, I'll get +1. Then 3 squared, I'll get 9. Then of course minus 3 into -1 over 3. So this will simplify into the following. So I'm going to have -1 over 27, then of course minus 4 over 9. Then this will remain to be 3 into 3, 1. So -1 times -1, I'll get a +1. So you feed this on the calculator, you'll get your y being equal to, so you take -1 over 27 minus 4 over 3 plus 1, your calculator will give you +14 over 27. Therefore, it means that my first turning point will be the x was -1/3, then comma, my y is 14 over 27. Therefore, this is the first turning point. So we compute the second turning point, whereby you're going to substitute the second value of y, that is x, in the given equation of y. So I'm going to substitute the second value. So when x is equals to 3, y will be equal to, the y was x cubed, then minus 4x squared, then minus 3x. So this will give me y is equals to, so this will be 3 cubed, then minus 4 into 3 squared, then minus 3 into 3. So this will be equal to 3 cubed is 27, then of course minus 4 into 3 squared will give me 9. Then of course minus 3 by 3, I'm gonna get 9. So this will be equal to 27. Then of course minus 4 times 9, I'll get that is 36. Then minus 9. You feed this on the calculator, you'll get negative 18. Therefore, it means that the second turning point will be x was 3. Then of course my y is negative 18. Therefore, the two turning points will be negative a third. That is the stationary points. Negative a third, 14 over 27. And the second turning point is 3, negative 18. So these are what we are calling our stationary points. These are the stationary points, or the turning points. Then we look at part C of the question, whereby we're being told to find the equation of the normal to the curve at the point when x is equals to 1. Of course, to get the equation of the normal, we need the gradient of the normal, and of course the that is the point where the normal is cutting that particular curve. So we start by getting the turning point. So the turning point, that is the dy dx. We get the gradient function, the dy dx. We had already differentiated our equation, which was the derivative of this. The equation was y is equals to x cubed. Y was equal to x cubed minus 4x squared minus 4x squared, then minus 3x, minus 3x. So the dy dx was 3x squared. Then the derivative of the second term was giving us minus 8x. Then this one was giving us minus 3. That was our dy dx. 3x squared minus 8x minus 3. So at this particular point, we need to get the gradient. So dy dx at the point when x is equals to 1 will be equal to 3 into 1 squared, then minus 8 into 1, then of course minus 3. So this will disintegrate into 3 minus 8 minus 3. So of course this will give us 3, and negative 3 will give us 0. So we'll remain with our gradient as negative 8. So remember, negative 8, this is the gradient of the curve, which is always equal to gradient of the tangent. So this one is the gradient of the tangent to the curve at the point x is equals to 1. But we know that since the tangent is always perpendicular, since the tangent is always perpendicular to the normal, it means that if we take the gradient of the tangent, you multiply with the gradient of the normal, we say these two must give you negative 1. So m1, m2 must give you negative 1. So if m1 is negative 8, so negative 8 times m2 should give us negative 1. Therefore, it means that our gradient of the normal will be given by, so I divide through by negative 8 over negative 8. So m2 will be equal to positive 1 over 8. That is negative, and negative will give us positive. Then you also need to get the y coordinates of when x is 1. So the equation was y is equals to x cubed minus 4x squared minus 3x. So when x is positive 1, y will be equal to positive 1 cubed minus 4 into positive 1 squared, then minus 3 into positive 1. So this will be 1 cubed is 1, then minus 1 squared is 1 times 4 will give us 4, then minus 3. So this will be equal to 1 minus 7, of course, which will give us negative 6. Therefore, it means that the point when x is 1 was given by, it was 1, negative 6. So to get the equation of the normal, we need a general point, that is x comma y, so that I let this to be x1 y1, then this to be x2 y2. So we know that gradient is given by change in y, which is y2 minus y1, over change in x, which is x2 minus x1. Therefore, on substituting those particular coordinates in my equation of the gradient is, my gradient was 1 over 8. So it means that I'm going to have 1 over 8 being equal to my y2, of course, is y. So this will be y minus my y1, of course, is negative 6. So minus 6 divided by x2, of course, is x minus x1, of course, is positive 1. But we know that negative multiplied by negative will give you a positive. So we're going to do a cross multiplication. So this one multiplies with that and this one with that. So I'll have 1 into x minus 1 being equal to 8 into y plus 6. So this will be x minus 1 being equal to 8y, then of course plus 8 multiplied by 6, I'm going to get 48. Therefore, I'll have x minus 1 minus 48 being equal to 8y. So x minus 49, this will be 49, will give me 8y. So I can rewrite it as 8y is equals to 8y is equals to x minus 49. So to get the equation in the general form, I'll divide through by 8 over 8 over 8. Therefore, my equation of the normal will be y is equals to 1 over 8x, then of course minus 49 over 8. Therefore, this is the equation of the normal to the curve. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscribe button and also turn on the notification bell so that whenever I upload a new video, you will get notified. Until next time, this is Kind Tuition Academy. Thank you very much.